I'm glad to be here with all of you and this great community. I'm Gerardo Huerta, and with Gabriela Zuñiga, we are working on this project about identification of climate change and sustainability texts using pre-trained Spanish language models. So what is our motivation to do this work or this project? Well, in this moment, there are many resources or many amount of different data sources that talk about climate change, its effects, its solutions, and also recent studies that maybe comes from scientific articles, journals, news, blogs, and opinions. But many of these sources of information are not collected in one place. So we got some inspiration from the project Drawdown, which is library solutions on many climate change solutions or examples of what we can do in this field to stop the climate change effects. So how can we bring all this information to the the general public, right? Or the correct people that may have the correct power to stop all the climate change effects. So we were thinking about creating a new tool capable of identify all these kind of tests, and in such a way that allows us to create more complex resources for our community, for our Spanish community, in order that they can build new data or new models that can be very useful for this kind of solutions. So there are many related words entirely in English. One of these projects is ClimateBear. ClimateBear is a project that they developed an LLM, which is intended to use for downstream task models using fine tuning. They got outstanding performance to climate change text classification, but we saw some difference because they use corporate documents to create their datasets. And also their data set is not balanced at all. So in this moment, we realized that we have an opportunity or chance to make a data set in Spanish and also cover all this field for these solutions, right? So what we do, or what we are doing in this moment, we are using this method or this methodology to collect all this information, all this data. We collect information for open source datasets. We use different formats for short and long text. Also, we did a pre-processing of these open source datasets, removing all the trash information like usernames, URLs, and also we did labeling like 0 for text that doesn't talk about climate change and 1 for text that talk about climate change. After that, we join all the pre-processing data, and we get these two kind of resulting data sets, like trained data and test data sets. We also did a third split, which is the validation data sets that we took information from these 4 resources, like the IEEE Climate Change Collection, which is a collection of papers that talk about recent studies in climate change. Also, the text from Project Drawdown, the Spanish Wikipedia, and also the Spanish news datasets. In total, were 200 tests in a balanced datasets. What we did was to fine-tuning a bias model. In this case, we used BERTI, which is a well-known Spanish-based model. And it has really key features like its size. It is a base model with a small size. And it has a good performance on taxes like text classifications. Finally, the results that we got from the training and test data sets, we use accuracy as metrics for simplicity. And we saw that the results are really outstanding. Also, we did the next stage of validation results. We wanted to be more in depth in this stage. So we have metrics like accuracy, precision, recall, and F1 score. And we noticed that on the precision, we have on the performance on the Wikipedia text, in the increase of false positive. And maybe we were thinking that the key factor was the lack of generalization on our training and test datasets. Finally, we had these conclusions and future work in this area. Our model can be a useful tool for identifying tests related to climate change and to create and enrich repository that is this subject. The following step that we are considering in this moment is create a new or generalization model that by taking data from different resources like the Wikipedia, the Spanish Wikipedia, and create an advanced model for token classification, not just to say that this text is for climate change solutions. Instead, we want to create a model that can classify on topics like renewable energy, agriculture, industry, transportation, etc. And we also want to train a question and answer modeling to see what is the performance of these all data informations in a model that could help you and get more information or solutions to the general public. We want to say some acknowledgements, like somos an NLP community. We thank all the event organizing experts for the support during the event. And we also want to acknowledge to Edison Bejarano, who was our translator on our paper and gave us valuable feedback. And if you want to get a look on our trained model, you can do a or get to or grade you demo. And that's all. Thank you.
Well, first of all, really cool to see a fellow Central American.
Yeah,
You know, I'm Guatemalan, so cool. But I was wondering, why were you only showing accuracy when, like, you were showing the evaluation over the test set and the evaluation over the validation set?
Yeah.
And you were showing all 4 metrics on validation, but only accuracy on test? Any particular reason why?
Yeah, this stage was because we wanted to use accuracy for simplicity, right? Because we didn't have the enough amount of data collected at that moment. Also, we wanted to get in the evaluation results to see like insights that what can we improve in a next stage, right? So maybe in a next stage, we can include all these other metrics and evaluate in a data set more general, like we have to include more data in our training and test data sets. Maybe that is the reason that why we choose only accuracy for this stage.